So today we're going to talk about exponential decay. The other day we did growth, so now this is just the opposite. Okay? I have a graph drawn over here that shows exponential decay, a decrease rapidly, and then kind of this flattening that happens. Over here I have the equation for exponential decay, and you'll notice it's very similar to exponential growth, with the exception of the minus inside of your set of parentheses. If you remember, exponential decay has to have a base that is smaller than 1. Okay, so this base is going to be greater than 0, smaller than 1. Okay, y is going to be the amount that you have after the time given. A is our initial amount, okay, same as before. R is going to be our percent represented as a decimal, and T is the amount of time that goes by. So I have a question here that is about Advil, and it says an adult takes 400 milligrams of Advil. Each hour, the amount in their system decreases by 29%. How much is left after 6 hours? Okay, so we are given in this problem, we are given the initial amount. They are taking 400 milligrams of Advil. Okay, we are given the percent of decrease, and we are told we want to know after 6 hours go by how much is left in their system. So the time is 6 hours. You have to also be careful of, and we'll continue with this as we go, you have to make sure you're dealing with the same unit of time. So in this problem, it told us that each hour we were decreasing by 29%, and we wanted to know after how many hours, right? Sometimes they'll give you it decreases by this percent in minutes, and then they want to know in how many hours is left. So be careful that you're still working within the same unit. I'll give you another example of that in another video, but just be mindful that if you're dealing with hours, you need to be dealing with hours, and if you're with feet, you have to be feet, or inches, okay? So keep your units the same. So my equation, y equals A, 400, times 1 minus r. Now, r, remember, has to be represented as a decimal. 29%, the decimal follows the 9. We have to divide by 100 or simply move your decimal point over 2 spots. So this is going to be 0.29. And then I'm raising this to the t power, but the t power here happens to be 6. Right? So we've got 400 times 1 minus 0.29 to the 6th power. This gets plugged right into your calculator, and we see 400 times 1 minus 0.29 raised to the 6th power. Now, you could very well, if you wanted to, before you do your equation, turn this into 0.71, because when you subtract 1 and 0.29, we get 0.71. It's the same deal. You get the same answer. Okay? So anyway, oh, and notice how that's smaller than 1, right? 0.71, smaller than 1. So 51.24. Okay? So there are 51.24 milligrams of Advil left after 6 hours. Okay? 51.24 milligrams left after 6 hours. We're going to take a look at finding the percent given the equation in the next video. So I hope you check that out. But this is exponential decay. Behaves almost identical to growth. It's 1 minus r inside of your parenthesis.